Okay, in this question we have another revenue question. So we have a theater charging $4 a ticket and had a full house at 400 people nightly. So their revenue is going to be the number of items, which is the people, 400, multiplied by the price per item, which is the ticket, which is 4. So currently their revenue is $1,600. But what they find is that ticket sales would decrease by 50, so the number of items would go down by multiples of 50 for each $1 increase in the cost. So every time I increase the cost by multiples of 1. So we want to find out what the maximum revenue is. So let's look at that. 400 tickets. So I'm going to have 400 tickets, but I'm going to decrease them by multiples of 50 every time my $4 ticket increases by multiples of 1. So that's my equation, and I'm going to apply the distributive property, get rid of my brackets, and complete the square. So 400 times 4, 1,600. 400 times 1x, 400x. Negative 50 times x, negative 200x. And negative 50x times 1, negative 50x squared. So writing that in descending powers of x, I have negative 50x squared, combining my like terms, 200x plus 1,600. So now I'm ready to complete the square, but I have to factor out whatever number is in front of my x terms. So my maximum is going to equal to negative 50. Let's factor that out. So negative 50x squared divided by negative 50 is x squared. 200x divided by negative 50 is going to be negative 4x. Leave some room, and then plus 1,600 on the outside. So to factor this, I look inside the brackets. I have my x squared, my 4x that I divide into 2 equal pieces. So factoring out a GCF and the leading coefficient, let's check to see if I did that right. X times x is x squared, x times negative 2 is negative 2x, negative 2 times x, negative 2x, and negative 2 times negative 2 is positive 4. So positive 4 will complete the square. So inside the brackets, I add and subtract 4, because 4 take away 4 is 0, and you can add 0 to any expression without changing its value. So that means that my maximum is negative 50 times, now let's complete the square, factor the perfect square trinomial, which I know from my grid factors as x minus 2 times x minus 2, or x minus 2 squared. Now, don't forget about the negative 4 inside the brackets. To take that out, I'm going to do negative 50 times negative 4 to bring it out, which is positive 200. And I will add that with the 1,600 that's already out there. So that means that my maximum revenue is negative 50, x minus 2 all squared. Add those two together is plus 1,800. So now let's state our vertex. Our vertex is opposite on the inside, straight up on the outside. So this is what my max or min is. This is when my max or min occurs. So what it is the maximum revenue. So the maximum revenue is going to be 1,800. So they're going from 1,600 to 1,800. When it happens when I have multiples of 2. Now what does that mean, multiples of 2? Let's go back up here. Multiples of 2. So if I decrease the people by multiples of 50, how many multiples of 50? Well, 2 multiples of 50. So my people are doing 400 minus 50 times 2, which is 400 take away 100, which is 100 tickets or people. And then the price, we said the price was increasing by multiples of 1. How many multiples? Well, 2 multiples of 1. So 4 plus 1 times 2 is 4 plus 2, which is $6. So let's look at the whole question to make sure we answered it correctly. So it says, what is the most profitable price to charge? So the most profitable price to charge is $6. Having 300 people attend, I would have a maximum revenue of $1,800.